Everywhere you go, plants are competing for light or competing for water or competing for nitrogen, nutrients in the soil. But it's sort of a new finding that in places such as the Arctic and the Alpine, stressful places for life to happen, that these facilitative interactions are actually really important in helping to shape landscape dynamics. We are in the Tatacoke River Black Brant colony, slightly outside at Tatacoke River Camp in the Yukon Delta, Alaska. My plots are situated here in this Carex rumenskii and dwarf shrub Salix ovalifolia meadow. This is sort of a wet meadow, part of the greater wetland ecosystem. This is a good example of a Carex rumenskii. This is a pretty common sedge out here in the Delta. This is the Salix ovalifolia, so this is a much woodier species that has these oval leaves. These are called runners, and they sort of spread out along the ground and have a more low-lying growth form. There's a lot of thought about how a warming climate is affecting especially shrubs, woody plants, and possibly increasing their density and range here in Alaska. So my project is working on how the interactions between these two plants work in the Delta. I got these OTCs on the ground in late April, just about as soon as the snow melted. All the vegetation was brown when I put them on, but my plots seem to be some of the first things to green up. So the OTCs, even though they're just using passive warming from solar radiation, they really do a good job at greening up the plots quickly, advancing the growing season, and then warming the climate throughout the season, but without reducing precipitation in the plots. My experiment, including the density manipulations, actually has 16 different treatments. I have 2 environmental variables that I'm manipulating. So I have 4 combinations of environments that you can have. And then I manipulated the density within those. In some areas, I didn't remove any vegetation, but in some areas, I removed quite a bit of vegetation. I'm actually trying to get at these really minute interactions between the plants. So I've developed some models to look at evidence of competition versus facilitation and sort of determine whether this Carex species, the Salix species, is coexisting together in this environment, whether they're competing with one another for resources or whether presence of one is actually encouraging presence of the other to exist in this environment. This is what I was so excited about yesterday. In the grazed plots, the Carex seemed to have a facilitative effect on the Salix. So in plots where there was Carex, the Salix did better when the plots were grazed. Carex, why is there no Salix removal over here? Having so many plots allows me to have the statistical power. I have 5 replicates, which is about the minimum that you need to make strong statistical suggestions about what is going on. With any fewer replicates than that, it's hard to have enough statistical power to draw any interesting conclusions. With an experiment like this, you're putting so much work into it. You really want to make sure that if you're seeing something, you're really capturing it in a way that you can report statistically and publish and share with the world. It would be a shame to do an experiment like this and find something really interesting but not have the statistical power to really draw those scientific conclusions that other people want to see. Scientific papers really want to see that you statistically have a good experimental design.